Okay, hello everyone, and happy Friday. It's the end of the first week of the fall semester. I hope that it's gone well for all of you. It's been a little bit of a roller coaster for me, to be honest, but still happy to be here talking to you about some computer science today. Going to be going over Studio Zero, so you should have hopefully completed Studio Zero in class on Wednesday and Thursday. What I typically do is I go through the studio and post a video, not necessarily to show you the correct way to do things. There isn't always going to be one correct way to do things, but just to kind of show you a solution. It might look like yours, it may not, but I'll also chat about the relevant computer science concepts along the way, and just hopefully make sure you have a good understanding of the studio and get you prepared for the upcoming homework assignment. So let's go ahead and dive right in. I've already got the studio tab open, and as many of you know, we actually had some problems right out of the gate this semester. Not uncommon, actually. The GitHub website was giving us some problems, so when you clicked on this link, it worked for some of you. It did not work for others, and the TAs kind of had to help you get set up. Fortunately for me, since I'm the instructor, the link will work for me. So I've created this repository, and I'm not going to show this every single time, but since it's the beginning of the semester, I thought it would be good to kind of give a quick review over how to get code into Eclipse. So this is what's called a repository, and right now it's only on the internet. It only exists on github.com. And I would like to get it in here in Eclipse so that I can work on it and write some code and make some changes to it. So I need to import it into Eclipse. I need to make a clone. That is what we would say. So if I click on this code button here, you'll see a link. I'm going to go ahead and copy that. And then I'm going to go over to Eclipse. I'm going to right click and import this. We're going to import a project from Git. Actually, I'm not sure what the difference between those two is. I think they both work, at least for me they do. We're going to select clone URI, and then it fills in the address for me. This bit down here, so that is my GitHub username, but this is not your GitHub password. So this is a kind of a confusing thing to have to show you right at the beginning of the semester. This is something called a personal access token. So we walked you through the instructions on the software setup and installation about how to create one of those. You have to use one of those personal access tokens here instead of your GitHub password. The reasons are to make it more secure, actually. That's basically the main reason why GitHub wants you to use those instead of passwords. But you can check this box here to make Eclipse remember it so that you don't have to remember that really long, gibberish looking string. I'm going to go ahead and click next. It'll go download the files and then load up the code for me after I click next a few more times, and then finally on this last screen it should say Studio Zero here in a moment. There it is, Studio Zero. I'll click finish. And on the left side now we can see the studio code is loaded up, and if I just expand down until I see where it says Studio Zero here, there's some files, some Java code files in here for us to look at and run and play around with today. So I'm going to go back to the instructions and see what it tells us to do for our first task. We're going to start with lunch receipt. So if we look at the file lunch receipt, it tells a story. It creates some variables up here at the top. We can see that the variables are appropriately named. We can tell actually what's happening in this file by looking at the names of the variables, the price of the various foods. We're adding up all of these different things that we supposedly purchased at a restaurant, right? We're taking the tax into account, multiplying that, and then adding up for our grand total, and then printing out the value. And we can actually run this in a couple of different ways. We can right-click this file, go down here and run as Java application, and it'll tell us that our total was $12.76. There's some extra stuff out here too. Some people ask me if we could do something about that. The answer is yes, actually we can do something about that. You'll learn how to fix that issue here pretty soon, for the first homework assignment, in fact. But for now, we're going to leave it as is. $12.76 for, this food seems pretty good, actually. That's a reasonable price for lunch. And so that's kind of the main thing, the main takeaway from this file is that because these were named appropriately, because the file was laid out in a nice structure, you could actually understand what was going on here, even though maybe this is the first code you've tried to look at by yourself, perhaps. Or maybe it's not. Maybe you've done some coding before. But either way, you can hopefully see that by, naming things appropriately and by just taking a little bit of care as to how things are sectioned in your code, that you can tell a little story. You can tell a little narrative. And that's what we're actually trying to do with our computer programs. We're trying to complete a task, tell a story, complete some kind of, narrative, some kind of action with our code. The other thing that we want you to do is toy around with breakpoints and the debugger. So there's nothing actually wrong with this code. There'll be some errors in the other files that we take a look at today, but we'd still like to walk through this step by step and just understand exactly what's going on as the computer runs this code. So the way that we can do that is by setting a breakpoint, and a breakpoint literally tells the computer to stop on a particular line. So it will run everything up to that line, and then it will stop, and it will wait there and wait for you to tell it what to do next. So I'm going to go ahead and set a breakpoint at the very first line here, line 7. You can do that in a couple ways. You can right-click and toggle breakpoint. You can see the little blue dot shows up, or you can just double-click. That also works, right? Either way, the next time you run the program, we need to start it in the debug mode. So we're going to right-click this time and go down to debug instead of run as. So that's what we did last time. We're going to do debug this time since we want to stop at the breakpoint. And now it kind of shifts things around a little bit. This is what's called debug mode. The window over here on the left looks a little bit different. The window over here on the right looks a little bit different. And you can see that the program has paused. It has actually stopped execution right now on line number 7, right where I told it to. It's waiting. It's waiting for me to tell it what to do next. So I have some options up here. What I can tell it to do next. This red square tells it to stop. So we'll just say, hey, stop what you're doing. The green triangle says, just keep going. Just run the rest of the program until you're done. But these buttons over here, these yellow arrows, are actually what we care about right now. And I'm not going to go between the difference between these two today. I'm going to save that for later. Right now I'm going to stick with the step over button, which allows us to progress through the code one line at a time. So after I click this button, since I'm starting here on line 7, I'll execute line 7 and end up on line 8. So I'll click that. You can see that I've now moved forward one line, and I'm now on line 8. Perhaps the more interesting thing, though, is that it's keeping track of the variables over here on the right side. So I can see that burrito price variable got created, as it says to do on line 7, and is being tracked over here on the right side of the screen. And if I keep stepping through these next variable declaration and assignment statements, you'll see that the variables get created over here. And as I do some of the more complex arithmetic down here, right, we can actually start to see the work that the computer is doing. We never actually see the subtotal get printed out, right? It just prints the grand total, the final total after everything's been computed, but the subtotal is just all of these added together. So, that's simple enough that you can kind of do it in your head. It's about 1225, right? So if we click next, you can see that that's exactly what the computer did. And this is why we use the debugger. We use the debugger to help us walk through our code one step at a time to make sure that we have told the computer what to do properly, that we haven't made any mistakes in our code anywhere, any arithmetic mistakes, any logic mistakes, any things like that, so that we can double check our work. You can imagine that as our programs get larger and more complex, it can get more difficult to find where the problems are. So if I try to run the whole program that's 1,000 lines long, and there's a problem on line 252, it can be tricky to find that problem. Using the debugger allows us to step through our code one step at a time to hopefully, make it easier for us to figure out, I should have done something different here. That's why everything else is getting messed up on the other side. So I'm going to go ahead and click resume to just go ahead and continue. There's actually nothing wrong with this program. I think it works pretty well for what it's intended to do. In order to switch back to being able to write code, I'm going to change the perspective, which you can do by clicking the Java button up here in the right-hand corner. And I'm going to move on to the next exercise, which according to the instructions is mileage report. Okay, so let's go ahead and open up mileage report. And just like the last one, it's trying to tell us a story. So here we can see at the top we're now using integers, and that makes sense. These are all integer values telling us, I'm guessing, how far 3 different cars have decided to drive. So they took some trips, and we do some arithmetic to get the total number of miles. Here it's telling us the miles per gallon for each of the car. So with that, we can compute the total number of gallons of gas. Here it's saying what the price per gallon is for a gallon of gas, and then computing the total price that we need to pay in gas. So the cars are traveling about 1,200 miles perhaps, right? And gas is about $3.05. That's actually kind of low for what it is right now. We're spending a whopping $93,000 on gas. So just to give you an idea, I mean, that's quite a large amount of money. It costs me not nearly that much to fill up my tank. I can probably go a few hundred miles on a tank of gas in my Honda Fit, and I can fill up a tank for, I don't know, 50, 60 bucks. So the idea that it would take $93,000 worth of gas to drive 1,000 miles does not really add up. These are some very, very, very bad cars, or we got ripped off, or I think actually more likely there's a mistake somewhere in our code. But where? Where's the mistake? Well, let's try and use the debugger to figure this out. I'm going to actually just kind of run through the same process as before. I'm going to set a breakpoint at line 6, or actually, if you are comfortable with these lines of code, since they are pretty straightforward, right? There's no arithmetic happening here. There's no math happening here. I don't think these lines are the problem. Maybe I'd rather set a breakpoint down here where I start doing some of the computations, where I start doing some of the the more complicated work. I'll set my breakpoint down here on line 10 instead. And now when I start this up in the debugger, you can see that when it stops, it just goes ahead and skips through those lines. They're already over here for me. And I pause on line 10 instead. Okay, that works just fine. So I'm going to go ahead and step over, and we should see the total miles. I did this one in my head, right? It's 1250. There we go. The miles per gallon is 24.5, and that's pretty reasonable. I mean, that's not an unusual value for miles per gallon, right? The total gallons of gas that is being used is 30,625, and there you go. That sounds like a problem to me. My gas tank holds maybe 12 gallons of gas. So, between 3 cars, I would expect, I don't know, maybe 50 gallons at the most. But this is a very, 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 very large amount of gas to be used. So something went wrong on line 12. And if we think about this real quick, the arithmetic mistake here is actually pretty obvious. The total number of miles times the miles per gallon does not give us the total number of gallons. It actually should be division instead. That's what we should be looking for. So yes, I think that is the mistake. We were using the wrong operation. In fact, let's just go ahead and stop this and rerun this program and see. Notice I just clicked the green circle this time instead of the debug to just run it normally so it won't stop at the breakpoint. Here we go. We now get a more reasonable amount of $155 for the amount of money spent on gas. That sounds a lot more realistic to me, considering the amount of miles that were driven by these cars and the miles per gallon that we're being told about. Okay, sounds good to me. Let's move on to the next exercise, Burrito Budget. So Burrito Budget, let me switch back to the Java perspective here. Burrito Budget tells another story. Here we can see we're creating some variables specifying the number of burritos that are being eaten in a given week. There's a big spike here on the number of burritos for week 3. Don't judge me. But then we add up how many burritos we've eaten over 4 weeks. We average the total number of burritos in a given week, and then if each burrito is $7.50, then the number, the average price that we're spending on burritos every week is what we're trying to figure out here, right? What is my burrito budget? How much am I spending on burritos every week? So if I run this program, it tells me that I'm spending $52.05 per week on burritos. Now, based on the values you see up here, you might say, well, you're eating a lot of burritos. That's, $52 may not seem that unreasonable, but I think it's a bit high, right? Even with this week 3 spike here, I think $52 a week on burritos, that's a bit high. There's a mistake somewhere in this code. Let's see if we can work it out. Again, I'm going to use the debugger here to see if we can figure out what the problem is. I don't think it's with this, right? These variables are just being declared and assigned. There's nothing really happening there. So I'm going to set the breakpoint on line 11, and I'm going to go ahead and click the little bug up here to jump into debug mode and see if I can figure out where the problem is. This should just add them up, so that should get me, what, about 31? That's not terrible math to do, right? 31. So 31 divided by 4 should get me, so 32 divided by 4 would be 8, right? 31 divided by 4 should be 3.75. I'm sorry, 7.75. And if I look at the result here, you can see that I actually got something different. I actually got 7. So the average burritos that I'm eating per week is not being computed properly. It's actually being underestimated, so that number is actually lower. Whoops. Anyway, but I think the more important thing to consider here is why. What's the issue? I actually illustrated this problem in class. It has to do with the way that this division is happening. Computers care not just about the values, but also about the types. So if we look at the types that are involved here, 4 is an integer, and total burritos has also been declared as an integer. An integer divided by an integer is going to give us an integer as a result. And even though we've declared the type of this variable as a double over here, right, it's too late. The division has already taken place, and since the result is going to be an integer, any decimal that occurs, like 0.75, is just going to get chopped off and thrown away. You can see it did not round it, it just threw out the decimal, just threw it away. Okay, so how do we fix this problem? Well, if we don't want the result of our division to be an integer, we have to make sure that one of the values involved in the division is not an integer. So you could change the type of this to be a double. That's one perfectly acceptable solution here. And if I switch back to the Java perspective and run this after making that change, you can see the number went up because I was underestimating how many burritos I was eating. Or if I wanted to keep this an int, because really it is an integer value, I could switch this to say 4.0. Now that makes this value a double, right? If I run this again, you'll see that I actually get the same value back out, 58.125. So either solution I think is perfectly fine. Okay? And now for our last example, this one actually doesn't really have much to do with coding and it has more to do with Git and GitHub. And also, I know that because of the GitHub issues that we ran into, that this worked for some of you and it didn't work for others. And that's okay. You know, this is part of the learning process. You get participation and credit in Studio just for showing up and giving your best effort. So whether it worked for you or not, no worries. I would like to show you what I believe to be the most important part of this exercise, which is how to commit and push your work. So this is what you're going to be asked to do every time you complete an assignment or a Studio for that matter. This is the way for you to take the work that is on your computer and send it to us so that we can examine your work if we would like to. So I'm just going to go ahead and make a change to this file. I'm going to make an edit to this, and I changed some other files too. You can actually tell which files I've changed by seeing this little mark here next to them, right? So these are the files that I've edited. And so if I want to send these changes to, well, actually before I do that real quick, let me go back to the repository page that I showed you at the very beginning. That's where I'm trying to send my changes to. So if I go to my GitHub repository, this page on GitHub, these are the files. So if I click in here, I can actually click and see there's Burrito Budget, lunch receipt. So these are all the files, but if I open them, right, it does not have the changes that I've made. These are the originals. These are the original unedited files. So I would like these to have the changes that I've made, right, so that other people can examine those as well. In order to do that, we need to perform what's called a commit and push. So I'm going to right-click the project, Studio 0. I'm going to go down to Team, and I'm going to select Commit. The files that I want to send to GitHub, I need to get into this staged changes box. So I'm going to take those 3 Java files and drag them down here. And actually, this is a common mistake here. If you ever see this mistake where you try and drag them and it doesn't work, just restart Eclipse. So let me just restart Eclipse here briefly. Or actually, restarting Eclipse is a good thing to try for just about any Eclipse problem that you run into. It's a quick and easy thing that fixes a surprising amount of issues. So if you ever run into Eclipse problems, just close it down, restart it, and see if you have any better luck. And there you go. Lo and behold, the files that I wanted to be down in staged changes are now down in staged changes. I'm going to type a message over here that indicates what these changes are. I'm going to say Studio 0 complete, right? And then I'll click the commit and push button. I'm actually performing 2 actions. Committing is like making a checkpoint, right? It's like saying this is a moment in time. It's like taking a snapshot, saying remember this moment in time. Pushing is then saying, all right, take that snapshot and send it up to GitHub. So when I click this button here, it's going to do exactly that. There's my commit message. And when I go back to github.com, if I view the GitHub page now, it tells me that there's my commit message, Studio 0 complete, happened just now. And if I click on here, I can actually see the files that I changed with the changes that I made. There's the Happy Friday message. So this is how you can actually check and make sure that your work has been submitted. In fact, I would highly, highly, highly recommend that you do this at least once after you finish every single assignment. Go on to GitHub, make sure you can see it on github.com. And honestly, you should do it more often than that, because if you ever lose your laptop, spill something on it, something like that, you'll still have a copy available that you can use so that you don't lose all of your work. Okay, that is the end of Studio 0. That is all that I have to show you for today. For next week, just as a reminder, we don't have lecture on Monday. It is a holiday, so happy Labor Day to everybody. I hope you have a good holiday weekend. We do have class on Wednesday and Thursday next week, so please take a look at assignment 0. And it's not a very long assignment, not a very hard assignment. Play around with it, bring it into class, and also please, 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 please take a look at the Module 1 exercises. You don't have to submit anything, you don't have to turn anything in. We're just asking that you look at this information. I posted a review video where I go through some of the exercises to help you with your understanding. This is normally what I would do in lecture, but since I don't have lecture on Monday, I'm doing the best that I can. So yeah, that's all for now. Have a great weekend, and I'll see you back in class next week.